Hi, this is Alex from devstories.eu. GeoDjango and PostGIS, Episode 7 of 15. Importing thousands of geographic polygons and their metadata manually could take days. Your source files have cryptic column names and mismatched types, but your database demands strict structure. The solution is GeoDjango's LayerMapping utility, which handles this entire ingestion process with exactly one dictionary. When dealing with spatial data, you often receive vector files like ESRI shapefiles. These files contain both the geometric shapes of locations and attribute data attached to those shapes. However, external files rarely match your database schema. A shapefile might have a population column abbreviated as POP 2005 and a country code listed as ISO 2. Your pristine Django model, let us call it World Border, has clearly named, strictly typed fields for those exact attributes. You might be tempted to use manual SQL imports or database tools like pgadmin to push this data into PostGIS. Layer mapping is a completely different approach. It is a programmatic Python script utility. It lives directly inside your Django project, tying external spatial files straight into your object relational mapper. Here is the key insight. The core of layer mapping is a simple Python dictionary. The keys of this dictionary are the names of your clean Django model fields. The values are the raw string names of the attributes in your source file. For example, your dictionary maps the Django model field's name to the shapefile attribute name. It maps your model's population field to POP 2005 and the ISO code fields to ISO 2. You also map the geometry field on your model to the geometry type of the shapefile, which is usually represented by a string like multi-polygon. To automate this, you write a short Python file, typically named a load script. Inside this script, you import your world border model and the layer mapping tool. You define your mapping dictionary, then you create a new layer mapping instance. You pass this instance three mandatory pieces of information. First, your Django model. Second, the file path to your source shapefile. Third, the mapping dictionary you just created. You can also provide optional arguments to control the ingestion behavior. If your source data is already in the exact spatial reference system your database expects, you can tell the utility not to perform coordinate transformations. This skips unnecessary calculations and speeds up the import. Finally, you call the save method on your layer mapping instance. When you execute this script, the utility takes over entirely. It opens the shapefile, iterates through every single geographic feature, and uses your dictionary to align the messy file attributes with your strict model fields. It automatically translates the raw geometry into a format PostGIS understands and saves the records into your database. You can instruct the save method to raise an exception on the first error it encounters, or you can let it run and simply log any problem features to your terminal. The single most important takeaway is that layer mapping completely decouples the rigid structure of external spatial files from the clean design of your database, letting you ingest massive datasets with just a few lines of Python. Before we wrap up, if you enjoy the show and want to help keep it going, you can support us by searching for DevStoriesEU on Patreon. That's all for this one. Thanks for listening and keep building.